The Arctic region might seem like a land of ice and snow, but beneath its frozen surface lies a hidden source of heat, geothermal energy. This heat originates deep within the Earth's core. It is a vast and clean energy source. The Arctic, particularly the area around Iceland, exhibits unique geological features that make it a prime location for tapping into this geothermal potential. Iceland sits atop the Mid-Atlantic Ridge. The Mid-Atlantic Ridge is a major tectonic plate boundary. Here, the North American and Eurasian plates are slowly pulling apart. This geological activity leads to intense geothermal activity. It manifests as volcanoes, geysers, and hot springs. The reason for this abundance of heat is simple. The Earth's crust is thinner in these geologically active regions. As a result, the molten rock, known as magma, is closer to the surface. This magma heats the surrounding rocks and groundwater. This creates geothermal reservoirs. These reservoirs can be tapped into using geothermal power plants to generate electricity. They can also be utilized directly for heating homes, greenhouses, and even melting ice on roads. Tectonic plate boundaries are the Earth's most dynamic geological features. They are zones where the massive plates that make up the Earth's lithosphere interact. These interactions are responsible for earthquakes, volcanoes, and the formation of mountain ranges. In the Arctic, the interaction of the North American and Eurasian plates creates a zone of intense geothermal activity. This makes it a hotspot for geothermal energy. The Mid-Atlantic Ridge is a divergent plate boundary. This means that the plates are moving apart. As they separate, magma from the Earth's mantle rises to fill the gap. This process is responsible for the creation of new oceanic crust. It also leads to the high heat flow observed in Iceland and other areas along the ridge. This heat flow makes it possible to access geothermal energy at shallower depths. This makes geothermal power plants more economically viable. The Earth's crust is the outermost solid layer of our planet. It varies in thickness. The crust is thinnest beneath the oceans and thickest beneath the continents. In certain parts of the Arctic, particularly around Iceland, the Earth's crust is remarkably thin. This thin crust is a significant factor contributing to the region's geothermal potential. The Earth's internal heat, originating from the core and radioactive decay, is constantly flowing towards the surface. In areas with thin crust, this heat doesn't have to travel as far. This results in higher heat flow. This means that geothermal reservoirs are closer to the surface. This makes them easier and less expensive to access. Success stories: Iceland and Alaska's geothermal triumph. Iceland and Alaska, two starkly beautiful lands shaped by ice and fire, showcase the remarkable potential of geothermal energy. Both regions have successfully harnessed their geothermal resources to generate electricity, heat homes, and even power greenhouses in the midst of harsh Arctic conditions.
Iceland, a pioneer in geothermal energy, has become a model for the world. Nearly 100% of Iceland's electricity comes from renewable sources. Geothermal energy makes up a significant portion of this. Iceland has also effectively utilized geothermal energy for heating, agriculture, and even industrial processes.
In Alaska, we've seen similar success. Our geothermal heating systems have made a huge difference in keeping homes warm during the harsh winters. Plus, the energy generated is clean and sustainable, which is crucial for our environment.
Powering Arctic communities, a renewable solution. For remote communities scattered across the Arctic, access to reliable and sustainable energy is often a significant challenge. The harsh climate, long distances, and dependence on fossil fuels make energy security a pressing concern. Geothermal energy offers a beacon of hope.
Geothermal power plants can provide a stable and continuous source of electricity, which is so important for these remote areas. This reduces reliance on diesel generators, which are both expensive and polluting. Geothermal energy can also be used for direct heating through district heating systems, reducing heating costs for individuals and communities.
Geothermals promise a sustainable future for the Arctic. The Arctic is warming faster than any other region on Earth. The consequences of climate change are already being felt, including melting glaciers, rising sea levels and thawing permafrost. Geothermal energy, with its low carbon footprint, offers a path towards a more sustainable future for the Arctic.
By transitioning away from fossil fuels and embracing geothermal energy, Arctic nations can significantly reduce their greenhouse gas emissions. This will contribute to global efforts to combat climate change. Moreover, geothermal energy can provide energy independence for these nations, reducing their vulnerability to fluctuations in global energy markets.
Indeed, geothermal energy holds great promise for a sustainable future in the Arctic, paving the way for cleaner energy solutions and a healthier planet.